What if every secure message or, medical record and bank transfer you've made in the last 10 years has a hidden expiration date?
Yeah, like a literal ticking clock on your privacy.
Right. A date when anyone with the right tool can just, open the file and read it. For a long time, the scientific consensus and even the U.S. government's official stance was that we had until the year 2035 to prepare for that tool to even exist.
Which was a nice, comfortable, decade-long buffer.
Exactly. We had a buffer. But in April 2026, that timeline just completely collapsed.
I mean, the world basically woke up to find that two parallel tracks of tech artificial intelligence and quantum computing had just violently collided.
Yeah.
And that collision accelerated the expiration date on global encryption by years.
Okay, let's unpack this. Our mission today on this deep dive is exploring a recent YouTube breakdown by Julia McCoy from April 2026. She really details exactly how this acceleration happened.
And it is a fascinating breakdown.
It really is.
Yeah.
But to understand why this is an urgent reality for you, the listener, and not just, a plot for some sci-fi thriller, we have to look at the actual mechanics of the internet's locks.
Right, the math problem.
Exactly.
Right.
Every time your browser shows that little padlock icon or you send a secure iMessage, you are relying on math. Specifically algorithms like RSA 2048.
Which is, at its core, essentially just a massive mathematical puzzle. RSA encryption relies on the sheer difficulty of factoring incredibly large prime numbers.
Right.
If you put the world's most powerful classical supercomputer on the task of breaking an RSA 2048 lock, it has to guess the factors sequentially. Like, it tries one combination, fails, tries the next.
A classical computer trying to escape a maze basically draws one line, hits a dead end, erases it, and, tries another path.
Exactly. And because the numbers are so massive, that sequential guessing game would take longer than the current age of the universe.
Which makes us feel pretty safe.
Yeah, very safe.
But a quantum computer doesn't work sequentially. A quantum computer floods the entire maze with water. Oh, I love that analogy. It's like regular computing bits are a coin flat on a table, right? It's either heads or tails, a 1 or a 0.
Yes, exactly. But a quantum bit, or a qubit, is like a coin spinning in the air.
So it's both 0 and 1 at the same time.
Right. That's a property called superposition. It isn't forced to be just a 0 or a 1. It can represent multiple states simultaneously. This allows the computer to explore vast mathematical landscapes all at the same time.
Finding the correct prime factors exponentially faster.
Exactly. It finds the key to the lock in a fraction of the time.
It turns a billion-year math problem into something that takes days. Or maybe even hours.
Yeah. But the caveat was always the hardware. Building a quantum computer capable of actually maintaining that superposition without crashing was considered just a monumental engineering hurdle.
And that's where that 2035 safety buffer came from, right?
Precisely. The assumption was that human scientists working at, normal human speeds would need at least another decade to build a machine with enough stable qubits to actually break common encryption standards.
Because they thought you'd need a machine with millions of physical qubits to get that kind of scale.
Millions, yeah. That was the underlying belief.
Okay, so then we get to the catalyst. The source material details these two back-to-back research papers that dropped in April 2026, and they just completely shattered that million-qubit assumption.
Yeah, that was a wild month.
First, Google's quantum AI team published a paper demonstrating a massive leap in efficiency. They showed a 20-fold reduction, and wait, that's 20 times, not 20%. A 20-fold reduction in the hardware needed to crack ECDSA 256.
And just for context, ECDSA is the encryption standard often used for digital signatures, like proving you are who you say you are online.
Right.
So a 20-fold reduction is a 2,000% improvement. That completely rewrites the roadmap for when that specific algorithm becomes vulnerable.
It's huge. But the second blow is what really dismantled the timeline.
Oh, the Caltech spinoff.
Yeah, or atomic. They proved that a totally different quantum architecture could potentially break RSA 2048 with as few as 10,000 to 20,000 qubits, not millions.
Which is a staggering drop.
I mean, they moved away from traditional superconducting circuits and used something called neutral atoms.
Right. So neutral atom architecture fundamentally changes the physical layout. Instead of relying on these rigid physical wires printed on a supercooled chip, they use highly focused lasers.
Wait, lasers?
Yeah, lasers to trap and suspend individual uncharged atoms in a flexible grid.
So they're just, like, floating there.
Exactly. And because you are manipulating these atoms with light, The qubits are reconfigurable. You can literally move them around during the calculation to optimize the connections.
Okay, hold on, though. I have to push back here. Hardware physics is notoriously stubborn. You can't just, wish away physical limitations.
True.
Scientists have been struggling with quantum layouts for decades. So how does the required number of physical qubits suddenly drop from millions to 10,000 virtually overnight?
Well, what's fascinating here is that the breakthrough wasn't just better lasers or better atoms. It was a completely different approach to the scientific method itself.
Okay, how so?
The researcher from Oratomic, Dolfstein, he actually explained this shift in Time magazine. He stated outright, "There is no question that we used AI to accelerate this development."
Wow. So the whole assumption that human scientists would be the ones slowly pushing this forward over the next decade, that's just dead.
Completely dead. Every previous prediction was based on human speed progress, but the bottleneck of human cognition has been totally removed from the equation.
Right.
I mean, finding the absolute perfect configuration for those laser-tracked atoms to run an encryption-breaking algorithm is an impossibly complex optimization problem.
A human team would have to, design an experiment, test a layout, analyze the failures over weeks, and slowly iterate.
Exactly. But an AI model, it can simulate millions of atomic grid layouts in the time it takes a human researcher to pour a cup of coffee. It basically acts as an insomniac co-scientist.
It doesn't sleep.
No, it just relentlessly finds the exact architectural shortcuts that humans simply couldn't see.
Which means the cost barrier completely collapses. If a practical quantum computer only needs 10 to 20,000 qubits, we are no longer talking about a $10 billion international moonshot project.
No, definitely.
We're talking about hardware that a well-funded, mid-sized tech company could eventually afford to just build or lease.
And that transition from a theoretical future threat to a commercially viable near-term reality that sent a massive shockwave through the organizations responsible for keeping the internet secure.
Oh, absolutely.
Yeah.
You see this perfectly illustrated with Cloudflare. They protect roughly 20% of all websites on the internet.
Yeah, 20% of the whole web.
They manage the traffic, they block the attacks, they secure the connections. And 2 days after these AI-driven quantum papers dropped, Cloudflare went into what a researcher described to Time magazine as real shock.
I mean, you have to consider the sheer logistical weight of what Cloudflare does.
Right.
Upgrading the underlying security protocols for a fifth of the global internet isn't just, a software patch you push out on a Friday afternoon.
No, it's massive.
It requires overhauling millions of servers, ensuring backward compatibility across thousands of different networks, and implementing entirely new quantum-resistant math without breaking the daily functions of the web.
And they were actively working on this upgrade, but their internal deadline was that comfortable 2035 date.
Yep.
But after seeing the data from Google and Oratomic, Cloudflare pulled their emergency post-quantum security deadline forward by 6 entire years, from 2035 to 2029.
Upgrading that massive infrastructure in 3 years instead of 9 is just a frantic, monumental undertaking. But they accelerated the timeline because they understand the true nature of the vulnerability.
Yeah, and here is where this gets genuinely interesting and, frankly, a bit terrifying.
Okay.
Cloudflare isn't just rushing to protect the data we send in 2029. They're trying to stop an invisible threat happening right now.
Harvest now, decrypt later.
Yes. Harvest now, decrypt later.
Yeah.
Okay, imagine a group of thieves breaking into a highly secure facility. They find the main vault, but they realize the titanium safes inside are completely impenetrable. They don't have the master key, and their current tools are totally useless.
Right, they can't get in.
So rather than leaving empty-handed, they just steal the locked safes themselves. They haul millions of these locked boxes off to a warehouse. They can't see what's inside today, but they are incredibly patient.
They'll just wait.
Exactly. They will simply store them for 5 or 10 years, waiting for the day someone finally invents a drill capable of piercing the titanium.
And in the digital ecosystem, state adversaries and sophisticated bad actors are executing this exact strategy today.
Right now.
Right now, they are actively harvesting massive rivers of encrypted data as it flows across fiber optic cables and global networks.
We're talking about petabytes of data here. Corporate trade secrets, proprietary algorithms, classified government files, and, vast databases of personal medical records.
They store this encrypted data in massive server farms. The current mathematical locks on that data are still unbroken. But they are stockpiling it because they know the moment a stable, AI-optimized quantum computer comes online, Those locks instantly expire.
And every intercepted message, every secure file they've collected over the past decade just becomes readable text.
It really forces a complete reevaluation of digital permanence.
It does.
The traditional mindset is that if data is encrypted during transmission, it is safe forever. The new reality dictates that if encrypted data is recorded, it will eventually be decrypted.
Which means an encrypted message you send tomorrow might be perfectly secure during transit, but it may not be a secret in 2030. If the adversary captures the file today, they just wait for the timeline to run out.
Exactly.
Now, you might naturally assume that this rapid pace of advancement has to hit a wall. I mean, in the tech world, massive leaps forward are usually followed by long plateaus as engineers grapple with new physical limitations.
Sure, that's the normal cycle.
But the source material outlines a compelling reason why a plateau isn't coming here. These technologies have formed an infinite loop.
Yeah, if we connect this to the bigger picture, the relationship between AI and quantum computing isn't a one-way street where AI just helps design better hardware. They are actively solving each other's deepest structural flaws.
Right. Let's look at NVIDIA, the giant of AI chips. They recently released an open-source family of AI models called Ising.
ISING.
Right. And this model wasn't built to generate text or images. It was built specifically to manage the most fragile aspect of quantum computing.
Which is error correction.
Yes.
Superposition is a highly unstable state. A qubit can lose its quantum properties, a process called decoherence, due to the slightest environmental interference.
Right, like what kind of interference?
Oh, a microscopic temperature fluctuation, a stray magnetic field, even a cosmic ray passing through the facility can cause the qubit to collapse back into a classical 0 or 1.
Oh, wow. So the spinning coin gets bumped and basically just falls flat on the table, ruining the entire calculation.
Exactly. To prevent that, classical quantum computing required dedicating massive amounts of computing power just to monitor and correct those errors in real time. It was highly inefficient.
Enter the AI.
Yes. NVIDIA's Ising model utilizes artificial intelligence to act as a highly advanced predictive filter. It anticipates and corrects the quantum noise and the result. A system delivering 2.5 times faster error correction and 3 times better accuracy.
So AI is actively patching quantum's biggest physical weakness, and meanwhile, the capital markets are just fueling this conversion.
While money is pouring in.
A startup named Sigildry, led by quantum pioneer Chad Rigetti, just raised $139 million with the explicit goal of building quantum-accelerated AI servers.
So you have a perfectly enclosed compounding feedback loop. Artificial intelligence optimizes the physical architecture and error correction of quantum computers.
Right.
Those more stable quantum computers then process specific mathematical problems exponentially faster.
And then that massive leap in processing power is fed back into training even more advanced AI models.
Wow. So AI accelerates quantum, quantum accelerates AI, which then further accelerates quantum.
It is a self-sustaining engine of exponential progress happening right now in real time. The friction of traditional human-led research has been entirely bypassed.
And that is exactly why a 2035 deadline can instantly become a 2029 deadline.
When you remove the friction of trial and error hardware design and replace it with AI simulation, the timeline for technological breakthroughs shrinks from decades to fiscal quarters.
Okay, so what does this all mean for you? If the mathematical foundation of the modern internet is actively being dismantled by this feedback loop and state actors are out there hoarding locked data, what practical steps should you take, like next Tuesday?
Well, the source is very clear that panic is not a productive response.
Don't panic. Good advice.
The major architects of the digital world, companies like Apple, Google, major financial institutions, they are deeply aware of this. They are already actively rewriting their infrastructure to utilize post-quantum cryptography, which involves entirely new mathematical puzzles designed to resist quantum factoring.
Right. Your bank account is not going to suddenly drain to zero overnight. It is a massive infrastructure transition, not an immediate digital apocalypse.
That's a relief.
Yeah.
But you can't outsource your entire security posture to massive tech companies, right?
Definitely not. The transition period will expose vulnerabilities at the individual user level, particularly concerning how we manage access.
So the source outlines 2 highly pragmatic actions you need to implement immediately. First, turn on a dedicated password manager and ensure every single account has a long, randomly generated unique password.
The logic behind this is tied directly to how hacks will unfold in this new era.
How so?
If a quantum computer breaks the underlying encryption of a massive database, say a retail company or a forum you use, the attackers won't just get the basic data. They will acquire the underlying hashes of user passwords.
Oh, I see.
So if you recycle the same password across your email, your banking portal, and your social media, a single database breach becomes a cascading failure of your entire digital identity.
Right. Unique passwords contain the blast radius. If one lock breaks, the thieves don't automatically get the keys to your entire life.
Exactly.
Okay, and the second vital step is enabling two-factor authentication, or 2FA, for every service that handles your money, your primary communications, or your identity.
Yes. Two-factor authentication is crucial because it creates a barrier that exists outside the realm of theoretical math.
I love the way the source framed this. A quantum computer is a machine designed to rip apart encryption math. It does not have the physical ability to reach into your pocket, take out your smartphone, and read the 6-digit code that was just texted to you.
Exactly.
Yeah.
Even if the quantum system instantly factors the prime numbers and shatters your password encryption, the login process halts until a physical, real-world action is taken.
It reintroduces a tangible lock into a purely mathematical vulnerability.
Which is your best defense.
Now, beyond just defensive strategies, the video's creator highlights an immense entrepreneurial opportunity here. She refers to this moment as requiring first-mover awareness.
Because we are witnessing the forced reconstruction of the Internet's foundational security layer.
Right. It is deeply reminiscent of the mid-1990s Internet boom. The companies that built the early infrastructure of the web became the trillion-dollar titans of the next era.
And right now, there is a massive vacuum. Entirely new companies are being formed to engineer the post-quantum security protocols, design the AI quantum hybrid servers, and manage the migration of legacy data.
So paying close attention to this space before it becomes mainstream cable news is a distinct advantage.
It really is. And it is also vital to recognize that this collision of AI and quantum mechanics is not inherently a narrative of doom.
Right, there's a bright side.
A huge bright side. The very same physical mechanisms that threaten global encryption possess the potential to fundamentally solve some of humanity's greatest challenges.
Because at their core, biology and chemistry are just incredibly complex math problems.
Exactly. The human body, global climate systems, the interaction of microscopic proteins, these are all systems governed by the interactions of atoms and molecules.
And classical computers struggle to simulate these interactions because the variables are just too massive and chaotic.
But a stable quantum computer, guided by an AI co-scientist, operates on the exact same physics as those molecules.
So it allows us to simulate nature natively.
Yes. The source points out that an AI-driven quantum system could reduce a 15-year drug discovery cycle down to 15 months.
Wow.
It can analyze the exact molecular structure of a disease and instantly simulate millions of chemical compounds to find the perfect countermeasure.
And it extends to everything. I mean, we will be able to run climate models that actually account for the chaotic variables of the Earth's atmosphere in real time, rather than relying on, historical approximations.
We'll discover and synthesize entirely new materials for battery storage or carbon capture that we haven't even theorized yet.
The video creator articulated this duality beautifully, I thought. She noted that when she read the atomic paper and fully grasped that the exact physical laws governing the atoms in our bodies were being harnessed to tear apart our digital security, her primary emotion wasn't fear.
No, it was awe.
She used this really striking metaphor. She said, "We are not gods commanding the universe. We are children who have just stumbled into a workshop our father built." We are walking around looking at these impossibly complex tools, and for the very first time, we are finally starting to read the fine print of physics.
It perfectly captures the sheer scale of the moment. The universe is fundamentally built on quantum mechanics, and after decades of struggling to understand the grammar, we are suddenly beginning to speak the language fluently.
And we have an AI co-scientist translating it for us at a speed we can barely comprehend. It is just an incredible paradigm shift.
True.
Well, that brings us to the end of our deep dive into this fascinating material. Thank you for joining us to explore this massive collision of AI and quantum computing. It is easy to view high-level physics as, an abstract academic exercise, but this shift to a post-quantum world is actively happening right now in the background of your daily life, forcing an upgrade to the very infrastructure that keeps your digital world functioning.
And as we wrap up, I want to leave you with a final thought to consider, circling back to that harvest now, decrypt later reality.
Right, the warehouse full of locked titanium safes.
Precisely. We know that state adversaries and various actors already possess petabytes of the world's encrypted data, sitting in cold storage, waiting for the day a quantum key is forged.
Yeah.
So consider the implications for global stability on the exact day those quantum locks finally click open. Are we marching blindly toward a quantum leaks era where an entire decade of the world's most guarded secrets, diplomatic back channels, corporate espionage, undisclosed military locations, and private communications are suddenly exposed to the light all at once?